Okay. Hello, data scientists, and we are here on another beautiful spring. Now, the first day of spring has come here in Australia. Dave Kilpinski, Troy Sadowski, and John Hawkins. John, a new face for the second episode of So You Think You're a Data Scientist. And we're really happy to have you. And yeah.
Thanks, Troy.
So we'll jump straight into having, a little intro from you about yourself and your journey as a data scientist and what you're doing now. And I heard and saw your book, which, if you could talk about you and your book, let's dive into that straight away.
Awesome. Yeah. So, like the sort of a good portion of data scientists, I came out of academia. So I was working in a field that's commonly called bioinformatics, which means I was applying machine learning and statistics to biological sequences. So it's things like, you process a sequence of amino acids that's kind of a new protein that we don't know much about, and you're trying to identify things that are called targeting sequences within them. So these are regions within the protein sequence that tells the cell, they're like postcodes that tells the cell where that protein is going to go in. Is it going to be transported back to the nucleus to work with DNA, or is it going to go to the membrane? Is it going to go to sort of other sort of organelles within the cell to perform specific functions? And so it's one of these ways that we learn more about new proteins by taking what we know about the sort of existing data set of proteins. So that probably sounds kind of similar to a lot of industrial applications of data science, where you're taking a set of data where you know some stuff and you've got new observations and you want to make inferences. So I'd gone through this process of getting my PhD in applied machine learning, working in that field, doing postdocs in Australia and Germany. And then when my wife was pregnant and we were looking to come back to Australia, it would seem like a reasonable time to transition to industry. And then that's when I kind of discovered that these specific skills I'd built up in academia or industry was starting to strongly demand them in a large amount. So I originally worked in ad tech, which I could talk more about that because that's where I've now ended up back working in with a company called Playground XYZ. But early on, I had the chance to work with a big data science team at the Commonwealth Bank of Australia. So that was kind of a real awakening for me, because it was the first time I got to work with data scientists from really varied backgrounds. So there was actuaries and physicists and engineers and other people from bioinformatics, different kind of numerical quantitative disciplines. And so I had this, so I was so excited about it. I was like, I'm going to take as many notes as I can about what works and what doesn't, and I'm going to kind of distill down this process of what it means to do good data science work. And right. As I was kind of explaining earlier, in that process, I realized that actually most of the reasons that projects sort of fail or don't have little to do with the technical specifics, because every data scientist has their own kind of favorite sort of toolbox of techniques. And actually, it's mostly about the sort of the top and the tail, which is the things about how you plan projects, frame problems, talk about metrics, communicate with stakeholders, then work with IT teams and engineers to actually deploy and monitor and make those solutions work. So that top and tail aspect is where most of my book ended up focusing on. So I took all those notes, and over the last sort of 6 years or so, I've tried to condense it down to a sort of sequential story that just talks about what it's like to go through a data science project, and where the kinds of problems you're likely to encounter, and a collection of sort of strategies that I've sort of come up with or seen other people work with to solve those problems. So the book's called Getting Data Science Done. You can sort of find it on Amazon and a few other places. But I'm really keen to hear what people think of it, because I'm consciously aware of the fact that it's come from my specific experience, and it's really interesting to see how that sort of meshes with other people's experiences.
Yeah.
Well, can I just say, John, a lot of what you were saying resonated with me personally in my journey into data science. I mean, I also have a pretty pretty lengthy academic background in quantum computing, and then having been in Silicon Valley as a data scientist for 7 years, working at companies of all different sizes on a lot of different kind of projects, including drug discovery. So we'll have to sometime chat about your bioinformatics work.
Awesome.
I would have to say, like, you know, what I've found is that there's a lot of people out there with a technical toolbox, but then the ability to actually, as you say, the top and tail, get the problem framing right, and get the desired outputs for business value. Those are really actually a little trickier to find.
Yeah.
And so in my own consulting practice that I run, that's really what I focus on. That's like 80% of the work, I would say. The technical side is relatively straightforward, actually, compared to the process of teasing out of people's psyches, like what's actually going to help your business.
Yeah.
And how do we turn that into a technical problem statement that then we can address in with the technical toolbox. And I feel, and on the other side, the tail, right, taking the results from the technical toolbox and reinterpreting them in terms of the business and in terms of the business value. And yeah, I think it's really exciting that you have a lot of really great ideas about how we can do that. Yeah, so I'm really excited to see this book come out.
Me
Awesome.
too.
Dave.
So yeah, and I think data science, you can come into it so many different angles, and people, and because it's so new, that, you know, we need more people like you, John, writing books that says, you know, this is what I believe data science is about and how I became a data scientist. I think, yeah, bioinformatics, a lot of people are coming out of bioinformatics into the data science field, but, you know, you also have come through that realization that it's just not about bioinformatics. It's about, you know, storytelling. It's about choosing a good toolbox or a toolkit. And this is the beauty of data science, because it's so new and the role of the data scientist still evolving. You can be a specialist data scientist in like healthcare, which is what my main industry has been and how I've progressed in as a data scientist. And I've chosen a toolkit that always, you know, I'm a Java guy. I mean, I love Python, and also, you know, dabbled in C and C# and that sort of thing for the, you know, IoT devices. But what happens is, when you come to a certain level of expertise, or what I like to call mastery, you can apply the techniques that I think I'm seeing coming out in your book, John, about, yeah, communication, the fundamentals of ensuring that you get the problem correct to start with, and ensuring that, you know, you can apply whatever technology or even learn a new tool to help in that situation. And yeah, so the journey really is to, okay, make a decision. I'm going to do more than bioinformatics. I'm going to be a data scientist, and that opens up the door to further, you know, developing your skills in communication, in storytelling, in identifying problems, and finding solutions, as well as the tools that fit, you know, that goal of how to solve the problem. And then, you know, if you are already skilled in those tools, I mean, you always, I do anyway, go to my, you know, my Java, because I know it so well, and, you know, it'll always play a part in the solution. I mean, if I don't see any other real number one reason to go away from Java, then I'll just stick with it. And that, I think, is important to, as a data scientist, to say, okay, yes, I'm a data scientist, this is my toolkit, and present that as you, because there's so many opportunities now in data science. People will come to you and say, yeah, I need exactly what you're offering. It's more than a statistician, it's more than a machine learning expert, it's more than a data manager, it's more than database developer, more than a software engineer. But yeah, I'm looking for a data scientist that can provide input to this particular problem.
Yeah,
And
awesome. I wonder, Troy, given that you started talking about sort of language choice and this, you know, like preferences and toolboxes, is that a good segue to Dave's? Dave had some ideas about topics we could discuss, particularly around that interface between data science and engineering. That could be a good segue point. Does that seem fair?
definitely. So yeah,
For
Dave,
sure.
you want to talk about, I mean, we touched on this as well in the last episode about the different, it's important to have these different roles or different types of duties that need to be done in large projects. And yeah, the communication aspect between like data engineer and data manager or software engineer is, I guess, in the context of when you are in a situation where you have, like in my case, you know, the luxury of a larger team to work with. It's there can be these different mindsets that we were touching on last episode that it's important to understand as well. So Dave, you want to talk to that?
Sure, yeah. So I mean, I've worked at companies where I was employee number 12. I've worked at companies where I was employee number 200,000. In my consulting practice has also spanned, you know, mostly on the smaller, newly funded startup kind of end, but also larger companies. And I guess, to my mind, the thing that comes up over and over again is less about tech stack and more about like the really fundamental dissimilarities in culture between data science and software engineering. I mean, I've seen situations where it comes out really clearly that these are almost diametrically opposed in some way. So from the tech stack point of view, I mean, I write mostly Python and SQL, but I read Clojure, Lua, C++, like, you know, R. There's like, I mean, as a data scientist, I think you're constantly in these situations where you're working with tech teams that have made engineering teams that have made different choices. It's really important to be able to read their choices. But the thing that comes up over and over again is more around the cultural difference. Like one really interesting cultural difference between data science and software engineering is that data science is fundamentally statistical, right? I mean, if you are modeling data and let's take a really simple example. You're cleaning a data set, right? You've got to apply different filters to strip out different kinds of data that you regard as, let's say, invalid, right? Now, from a software engineering point of view, the correct thing to do that one is taught as a software engineer is to identify every possible edge case and guard against every possible edge case, ideally through testing, although that 100% test coverage is never achieved, right? But as a data scientist, you come at it from this quite different approach where you're thinking, well, I need to focus on what are the problems in the data that come up in a big way, right? Because as a statistician, I know I can, to some extent, afford to ignore problems that only come up that last 0.1% of the time. And so when you're trying to make trade-offs about the speed of a project and how the project is progressing, like one thing that I found in my consulting practice is that you can be working with software engineers who are like, oh, we really need to nail down these these extra 10 edge cases.
Yeah.
And I'm sitting there thinking, well, you know, this isn't necessarily going to move the project forward in a useful way because they only account for 0.1% of the total data. And I think probably the modeling that we're doing can tolerate that kind of inaccuracy.
Yeah.
So, and then on the flip side, data scientists often don't appreciate the importance of well-tested code.
Yeah.
Because a lot of what we do as data scientists, especially on the modeling end, it can be hard to render it deterministic, for instance, in the way that a code logic flow is deterministic.
Yeah.
And so and also there's a feeling that, well, the model kind of spits out whatever it spits out. And then you're thinking, well, yeah, I mean, you're not going to know exactly what's supposed to come out, but concepts like regression testing are still really, from software engineering, are still really important in, let's say, the modeling space. And so one interest of mine is, how can we sort of blend these together? I mean, I think a lot about ideas like what I like to call statistical unit testing, where you accept that the output of a function is going to have a statistical distribution, but then you apply a statistical test to see, well, is this distribution really different from what I expect in key ways? Is the statistical distribution really different from what I expect in key ways? And by the way, this circles back to software engineering in an interesting way, because from my work in DevOps, I know that there are lots of unit tests that are flaky. Like you try to get a response, like you have a unit test that relies on a response from a server, let's say. Well, the server's down. And so your CI/CD flow, is nominally broken, right? You could have 100 of those tests. If one of them fails, your PR isn't going to get merged, right? So even on the software side, there is an understanding, though, of statistics, because people retry their unit tests and do majority vote, let's say. So it's not like, so this concept of statistical unit testing even does exist on the engineering side in a certain way. But there's a fundamental difference in psychology, and that creates interesting communication barriers sometimes.
Yeah, I agree 100%, Dave. And actually, and I really like your idea of statistical unit testing. So I was thinking about it a little bit this week after I saw the last episode. But actually, I wanted to just rewind a little bit to your sort of discussion of the fundamental cultural difference between the two teams. And I think in part it stems from the kind of tasks they typically do. So quite often, even though data science more and more is about getting things into production, it still has a large element of, like a lot of any kind of applied computer science research, which is get answers fast, which means writing throwaway code that you don't have to maintain in a year or two's time. So because of that emphasis on fast answers, it's a different coding style and different cultural practice, whereas engineers have an entire culture dedicated to writing maintainable long-term code. And so it's understanding those two. That's the source, I think, of that kind of major cultural difference.
Exactly.
Oh, yeah.
Yeah, well, the way I've come into it, is really in that what we call scientific software development. I've been employed as a scientific software engineer, which is, you do things fast. It's just sometimes you write code that's just used once for the researchers and for them to see, okay, what's going to happen here. And yeah, I think coming into that space, and also with experience in production type engineering or software development and understanding those aspects, that's what makes me, I think, stand out as a data scientist, because I can talk to those that are doing scientific software development. I can say, okay, take this approach. Or they're already going to take that approach, and then I can jump down and talk to the engineers and say, yeah, smooth out that kind of cultural differences as much as you can, and so that everybody's kind of on the same page. And if you're lucky enough to be, the owner of the kind of product or project, then you can get in there, write some code at some production level, also do the aspects of scientific software, just a quick test, a throwaway solution. But it's the role of being able to jump up and down and communicate across it, that's what I believe, makes a great data scientist. And each to their own, because you're going to have in a large scale enterprise organization, people that are strict engineers and they want, the code to last. And then you're going to have people that are more scientific based and just experimental and exploratory. And being able to understand and talk the language or adopt the mindset or understand that people come from different perspectives and different levels is key to doing the data scientist role. And I think that comes back to a lot you're saying, John, around communication being fundamental.
And I think it's also largely about empathy as well too. I think people, a lot of data science teams have this unfortunate element of coming to resent IT and engineering,
right,
because they feel like they're standing in their way. But I think it's always important to keep top of mind is, if this thing fails, are you going to be coming on the weekend to fix it? And if you're not, then you need to sort of have like a little bit of reverence for the people who have to do that stuff.
Exactly.
Well, I've been on pager duty, I can tell you that. at Stitch Fix, at Stitch Fix, in fact, every data scientist had to take rotation on pager duty.
Wow, that's awesome.
So, and when the model fell over, oh, you heard about it on your mobile. Not that would ever happen to me.
I think, another unique perspective perhaps that I hold is that data science has been around for a very long time before it was even called data science. I can see data science in everything, and even, in cave paintings where people are making their mark on the caves, and that's a data storage, and it has a meaning and it has a reason, it has a communication aspect, until we jump through the decades and thousands of years to get to the first aspects of a telegraph, sending messages through Morse code, beep, 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 beep. And then, there's all this data being stored up. These are the messages that need to be sent. And, what an interesting point also is like the power that comes as a data scientist, or being accessing this knowledge or this data. So because, that Morse code interpreter would be seeing all these messages, they would have the power to be able to predict what's going to happen, what's, perhaps inside information. And that's, the main reason I see around data science is that, we want to utilize the data because of how fast technology has grown and how much data is out there now. It has really called for a new role, and we all did, I believe, and could be considered data scientists in our lifetime, no matter what we're doing, because we're working with data as I see it, and we are, problem solving. But not everybody chooses to be a data scientist. It's kind of like photography. Like, everybody's taken probably a photo in their life, but not everybody takes photography on as a career. But because of the situation of how much data we've got and how fast technology moves and all the tools that are out there, it has called for this new role called the data scientist. And it's those that are brave enough, those that are feeling like they're up for the challenge and can go through, the stages that I see all of us have gone through, to say, I'm a data scientist. So, over to you, John, I guess. And what are your thoughts on my opinion about, everybody being a data scientist, but just don't choose to be a data scientist?
I mean, I think it kind of, I don't really have particularly strong opinions on any of that. I think we're all exposed to data and information that we have to interpret, and so you could say in some sense that we're engaging in a career where we're trying to refine that specific skill, I guess. It's an evolution of what statisticians were doing, except that it's sort of merging into computer science. It's about, it's about when you've got large amounts of data and you can think about both separating inference and prediction and the many different kinds of ways you want to distill information from data. It's a merging of these disciplines and a refinement of a particular skill set. But you have to choose. You have to choose to do that and to put in the effort, and also where you want to focus your time. I am looking forward to see. I think you should perhaps change the image for the page. Like, I want to see that sort of cave painting interpretation of data.
Right. I actually want to see the job descriptions from recruiters 40,000 years ago. I think that would be intensely interesting. Experienced with bow and arrow technology, 5+ years.
Yeah, I mean, that's how things evolved. I mean, that's why I think, 50 years or maybe 70 years ago, computer science didn't exist. So it's not till, the last 10, 15 or maybe 20 years, data science didn't exist before then. But it really, as the fundamentals, I mean, it didn't exist as a role, the data scientists, but the fundamentals still existed around looking at information, deriving meaning, getting insights, utilizing what we have, whether it's bows and arrows or spears. Those are the ones that led the way and said, I've found a new invention. And this is what really interests me, is the inventive side, and to be in that space of new inventions, new ways of seeing the world, new ways of, restructuring how we do things. Because I also think a lot of systems are broken right now. And yeah, in order to solve these big, large issues, the data scientist is here and almost is essential to have on a project that you're looking to do really innovative, leading edge inventions or technology or solutions.
I think actually, if I could kind of, after I watched your first episode, I know one of the things that I kind of really strongly agreed with that you were talking about was just the idea that sort of scientific thinking is kind of essential to the process. Like that you're not a technician. There's a sort of way of thinking about how you sort of extract new knowledge from data. But I wanted to add something else to that, and that is, I think, another potentially sort of underemphasized aspect of data science is you also have to have almost pathological curiosity, because you can't, it's not the technical skills are not enough. You have to really care about how businesses function. You have to understand who their customers are, where the cash comes from, where their inefficiencies are, care about that so much that you ask all of the right questions to really understand the problem, so that when you derive a solution, it's actually going to add value to the company. Because otherwise, you're just someone who's being given a project scope and then writing some code to sort of solve whatever the perceived problem you're given is. Does that make sense? Like it's much more about engaging in the thought process to help people who don't necessarily have that deep understanding of computer science, ML, statistics, and helping them frame something that gives them value.
That's right.
Well, and this issue also comes up on the software engineering side, by the way. Right, similar issues where the software engineering people they think of themselves as being in this little box, and there's inputs to the box, namely specifications, and outputs, code that meets the specifications.
Yeah.
And a lot of the time there's a disconnect between the people in the box and the business.
Yeah.
Right. So I think what you're saying actually applies more broadly than just data science. It's like, anybody who's working in a business, who is any technical person who's working in a business is always gonna need to have that appreciation for the interface between the business needs and the technical ways to solve them.
Yeah, I think that's true. I think that's true, but I think in the case of software engineering, being an older, more developed and discipline with sort of like, I guess, richer frameworks, they will have things like product managers and product design. like people who take on that role of the interface with the business, whereas we don't really have that so much in data science. We don't really have a whole discipline of data science product managers. We don't have those people in that role who have the requisite background knowledge to sort of understand that interface.
Yeah, I would certainly agree with that. I mean, I have worked on teams of product managers that were structured as like a, you know, much like a more traditional software engineering team, but now we're going to add a data scientist and maybe a data engineer,
Yeah.
right? And that's absolutely true. I mean, the product managers generally are much more comfortable with the software engineering way of looking at things.
Yeah.
But again, going back and forth between data science and software engineering requires you to really shift gears a lot. And you know, just touching back on the point of the interface between software engineering and data science, I feel like that ability for the data scientist to shift gears back and forth between highly iterative experimental coding style and then like knowing when is it time to pay off some of this tech debt.
Yeah.
That's something that we as data scientists really have to take on as our own responsibility.
Yeah.
Because other people aren't going to do that for us. I mean, as someone who's put a couple of data science or machine learning systems into production for like $100 million teams, I can say like there is not going to be some software engineer who comes and takes your code and turns it into like the modeling part, okay, and turns it into production hardened model. I mean, these days, like it seems to me that ML engineer really means someone who maybe writes a microservice that calls your model, right? But that's actually a completely different thing from taking the modeling code itself and making sure that it is suitable for production, right?
So, yeah, the way I see it, I mean, can you guys hear me?
Yeah.
Yes.
I mean,
Yes.
Is that what I believe you're talking about is the domain. I mean, to get buy-in, to have buy-in as a data scientist, I mean, you can come in multiple ways. If you are, you know, working on a project where you have shares in the company, or you know, you are the owner of the product in terms of what you're developing, it's going to be in something you're passionate about. And this is what my advice, and when data scientists or aspiring data scientists come to me, it's like choose your domain as fast as you can. I mean, mine, I've been lucky enough to kind of fall into it with its healthcare and cancer research. And that, because data science can be applied in any domain, any industry, gives you also this capability to get noticed in terms of, yeah, we need a data scientist who has cancer background research, epidemiology interest. Okay, there's Troy Sadowski, or there's another data scientist. It might be, you know, in terms of the toolkit and the understanding, you know, machine learning and all these aspects of process involved. But what comes out on top, I believe, is their drive, the passion to say, okay, do you want to, will you work on the weekends? They will say yes, because it's in an interest of their own, and it's not just a job, it's kind of a passion. And moving away from, okay, I'm going to sign in as a data scientist, okay, yeah, it's 9 a.m, okay, well, yeah, it's 5, I'm going. That yeah, is all important to go through those stages as you're developing your career as a data scientist, but to get as quickly as you can to this space where it's not work anymore. It's kind of an enjoyable scientific research aspect mixed with, you know, rigorous engineering process, and to come up with new inventions and new ways of seeing the world. That's what I see the opportunity that the data scientist role has. And that's, you know, the purpose, I believe, of this series is to inspire people about these bigger pictures of where data science can go and what the data scientist role can do.
Very good. Well, it looks like we're about at the half hour now, Troy.
Yeah.
So that's an inspirational note to end on. John, did you have any final comments? Anything that thank you so much for coming on with us, and hopefully that can happen again sometime.
Yeah.
Yeah, did you have any final thoughts that you wanted to share?
No, that was good. I think that was great. I think we followed a nice story arc. So thank you guys. This was fun. Let's do it again.
Great.
Brilliant.
Yeah, thanks again, John. Thanks, Dave. And for all those viewers that are watching, please reach out to us through either datascientists.com or the LinkedIn group, which is now growing, about 100 new requests per day. And we're about to hit 180,000 members. So check out those resources to stay in touch. And of course, yeah, like almost every YouTube video, hit the subscribe button and yeah, stay in touch.
Awesome.
Thanks, guys.
Great. Thank you.
Cheers.
Bye.
Take care.